of you are actually ahead of schedule. And you're probably gonna be like, really, I don't feel ahead, but if you look at the calendar, we got all next week and then like 3 more days for labs, and on your schedule, the last 2 days of those 3 days are kind of cleanup days. So most of you are probably ahead on your labs, but I would go through and kind of check it and say, hey, where actually am I at in life? And I probably got 2 extra days. If you go through and check it and go, whoa, I am not ahead, well then you're the one that's gotta get in gear. But lots of lab time coming at you. Talking about stealth bombers today. If a pterodactyl's flying over you and urinates, why don't you hear it? The P is silent.
Oh, you got it, good.
What?
Those are good.
Alright, hydraulic filters. When we check for fluid contamination, what are we checking for? Oh no, somebody moved all the names. Let's do one of the other instructors. Christina's moving them, that's okay. Nathan, there are 2 basic families of contamination when we're talking hydraulics, hydraulic fluid, I should say. So what are we checking for? There are 2 types of contamination. You got one of them right. Debris would be one. Water would fit into the other category. What's the other category, Kurt? Anything other than debris? Anything other than hydraulic? You're in the same camp as Nathan, where you're like dancing around the edge, but it's probably not going to be accepted as an answer on your exam. Hint, hint. Christian Chatterquist. Cross-contamination. We'll count that. Yeah, we'll count that. So you would call it, cross-contamination is great. Cross-contamination would be like a chemical contamination as we have. Now I can't think of the word. But yeah. So our filters are taking out the particulate. Our filters, for the most part in hydraulics, they're not going to deal with the cross-contamination. What's this word? Because I can't think of it.
This is what I remember.
I know, yeah, you're good. I have it, I'm going to go back to slide 1, but chemical contamination, there's a word we used. But it's just the particulate.
Do we ever use water block filters in hydraulics?
Very rarely, yep. Part of that is we do often have, where I'm going to use the word introducing air into our system. You know, bleed air is pushing air in. Hopefully it's fairly dry air, but we're bubbling air in our fluids as they go flying back into our reservoir and stuff. So yeah, it's pretty rare to have any sort of water filters in our hydraulic system. So our fluids hold in suspension, we like to say they hold in suspension the tiny particles of metal that are normal wear. It calls that in chapter 12 of your book, it'll say, well, normal is to have, tiny little particles. So say your pumps are running around, you might have some tiny particles that break off and they get in your fluid and the fluid holds them in suspension. So they do say that's normal wear, they're small enough. So we need to capture these before they cycle through the system and cause damage. You've been taking apart those pumps and you can see they're extremely tight tolerances, and we need to take anything out that would get in there and damage it. We could have filters in a lot of different locations. We always like to say that we have filters by the reservoir. We just love to say that one. Could be the pressure line, could be the return line, really anywhere the engineer says, but they like that answer of the reservoir. If you get a big aircraft, we will often have them block like this where they throw the filters on and then they throw a bunch of other components. So these components here, for instance, if I can use the word components, would be where you'd hook up the ground mule to it. That way you don't have to pop the cap on the reservoir and pour fluid in. You just take that disconnect off. It's got a low leak fitting in there or a no leak fitting. It's a check valve. Screw on your new hose and pump some hydraulic fluid in. And on a real nice system, you can actually put in pressurized fluid. So say the beach jet's jacked up, you can just connect your mule to that. You don't have any leakage. Turn on the hydraulic pump and you can run your whole hydraulic system off that. So a lot of times we're going to have a filter module and or it can be built into your reservoir as well. So on here we've got a whole bunch of stuff. If I've got wires going to it, it's probably either a pressure switch or a pressure transducer. And Matthew Blosser, where'd my sheet go? Matthew Blosser, what is a pressure transducer? Any transducer for that matter, but pressure specifically. Exactly, changes the pressure into an electrical signal. We also are going to have pressure indicators, and we're going to have some, I'm going to use the word pressure indicators that are like a tattletale that say, hey, my filter is plugged, the pressure got too high, and I want you to know about it. So they'll be in various places. I'm going to pass this one around. It's got it on the bottom of it, so I'm going to give it a head start. And you can kind of look at that red button. If that red button were to pop out, you'd go, huh, at some point the pressure across my filter got too high. I better change that hydraulic filter. This one doesn't show them very good. This one, where it says press here, those little dudes, if the pressure got too high, they'd pop out and you'd get a visual indicator that the pressures are dirty. But back to the filters first for a little bit. Several types. We've got our micron filter. Normally when we say micron filter, we're dealing with these paper guys, so they're going to catch very small particles. We also have just porous metal screens, which, you know, it looks like a nice filter, but nowhere near as tight of particles are going to get caught by these porous metal screens. I'm not going to pass these all around. When you're in lab, come explore some filters. It's kind of fun. So micron porous metal screens, and they throw in there, and I didn't bring any up here, they throw in their magnetic. Now magnetic filter, when we use that word filter, we're being generous, right? Basically you'll have a magnet that is screwed in somewhere, and as little magnetic particles go by, it's attracted to them and they stick to the end, and then you can pull it out and go, oh man, I got a bunch of magnetic material on here. So the magnetic filters, think less like a screen, more just it's a magnet that's in there to grab onto anything that might be magnetic that's going by. And quick reminder, microns are tiny. Millionth of a meter. They're small. So, if we stick enough stuff, dust, little tiny normal metal shavings, not shavings, that's not the right word, metal particles. If we stick enough of them in our filter, it's going to be hard for the fluid to get through our filter, and the pressure's going to go up. So here's a little bit bigger blow-up view of your tattletale, but actually the whole bypass valve. So this is your filter here. The fluid's coming in. In normal operation, the fluid comes in, it goes through the filter, and it goes back out to whatever's next in line. Pretty easy, right? Pretty much without exception, pretty much. We always go from the outside of the filter to the inside of the filter. They're much stronger that way. They can handle the pressure better. So it works well, outside to inside. So our pressure also can travel around the outside of this thing, and it gets up into here, and this is sealed, so it doesn't go up in there. But if the pressure difference between after the filter here and before the filter here gets too high, it'll push down this magnet plunger that's on a spring. So the spring is obviously a calibrated amount of force. And if it pushes that magnet down, basically it releases the magnet it was stuck to on this side, and the little shaft goes up and pop, the little thing comes out and says, hey, the pressure difference got too high. So that's how they often do this, to make sure that the button is not seeing 1,000 PSI itself. The button is magnetic, it's a hold-in magnetic button, and it just pops out. So that's a pretty common way to do it, and we'll stay here. A lot of times they will have a thermal lockout on them. I believe that one we passed around has a thermal lockout on it. If you read it closely, you'll notice it has a temperature where it's like doesn't work below blah 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 temperature. The idea is, say we first jump in our aircraft and start it up, all our hydraulic fluids are cooler. They're cooler or cold. If a fluid is cold, it tends to be more viscous, more resistance to flow, and it might have a higher pressure drop until that fluid warms up. So we don't want to start up the aircraft and have all these little pressure things going pop, 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 pop all over the aircraft, and then the mechanics go, all our filters are plugged. So somebody got creative, and they've got a bimetal device. Bimetal being two metals that expand at a different rate, right? So the inside metal is going to expand more when it's hot. So when it's cold, it shrinks down, and this is a side view of the button. So when it's cold, it covers the button can't move. But as it warms up and opens up, okay, now the button can pop if I have a bigger pressure difference. So basically you got a little thermometer, for lack of a better word, that's saying, well, when it's cold, I'm gonna hold you down, I'm not gonna let you pop. But once I'm warmed up, once you're warm, well, now if I have a pressure drop across my filter, pop up for that visual indicator. You go, well, isn't it gonna destroy the filter if you got a big pressure drop when it's cold? Well, yeah, no, it's not gonna destroy the filter, because this is a relief valve of sorts. It's a bypass valve, we would call it. So our pressure comes in, say my fluid is super cold, and it'll be like, you know what, we're not gonna filter you right now. We're gonna let you bypass the filter because it's too high of a pressure difference. So what's gonna be set higher? The bypass pressure or the trip pressure? Heat heights. Little logic for the day. Which is going to be a higher pressure setting? The alert or the relief? The trip's going to be higher? Unfortunately, you're backwards. If the trip was higher, it would never trip. Because let's say the trip is set to 500 PSI, and the relief is set to 475 PSI. Would we ever get to 500 PSI? No, we're never gonna get there. So, the relief is always gonna be set higher, because basically in normal operation, we would want that to say, hey, I got a filter problem, and then shortly after that, and I'm just gonna bypass so we don't destroy the system, right? So thinking through that, you go, okay, yep, I see what's going on there. Tiki?
Why do we need this for warm temperatures but not cold?
So when the fluid is cold, it's more viscous, and it's just gonna trip our indicators. So we expect the fluids to be operating temperature. So when you go to start, you're from Florida. In Michigan here, when you start your car in the morning, the oil is very, very cold, and your oil pressure is like, wah, because it can't get through all the tight passages and stuff like that. So until the hydraulic fluid, which is an oil of sorts, warms up to operating temperature, you're going to expect a higher pressure drop because it can't get through these tiny micron holes in our filters very well. Once once it warms up, it goes through just fine. Let's see, food related, how could we relate that to food? A cold food that won't pour. What? I haven't used molasses in years.
Honey.
Honey, do you ever eat honey on anything?
Yes,
Honey, so, you tracking with me? Okay,
I was.
she was, alright. Jedediah, 7.
Are there rules, for pilots when they first start up the aircraft to like push the DPI buttons back in, wait 10, 15 minutes, see if it pops back out again?
Generally speaking, if it pops, the mechanic's gotta figure out why. So if you're going through the beach manual, if you see it's popped, generally speaking, you gotta figure out why. And that's why they put these on here, cause they don't want you chasing a false alarm around. So usually if it pops, you gotta figure out why. It's gonna be in whatever manual, whatever airframe you're in. But yeah, it is a warning, so we try not to ignore warnings. But I'm sure different airframes have different rules for if it pops once or pops twice.
So we have a basic, I don't know if it's a rule, but they tell us like we can push it in at least twice.
Okay,
But it's because of the temperature changes, fluctuations, and then you let it run so the fluid warms up and becomes more.
yeah.
So,
And you might not have that on your buttons, for instance.
okay.
Tiki,
So could a temperature change alone without anything being wrong with the system cause the button to pop?
all depends if it has one of those or not. If it has one of those, no, because that would keep it from popping when it's cold. Did I see another hand?
Yeah, so this button is like on the housing itself, right?
Yep, it's on the bottom of the one I passed around, and we'll send this one around right now. On this one, should I just make you find it? No, I'm gonna point it out. There it is, right here. Filter indicator hanging off the side. I thought there was more than one, but I would think there's one for each filter. Oh yeah, here's the other one, hanging off the side. So, somehow this leaks out of one of these at some point, so I'm gonna send the rag around with it. I figure at some point, all the food will be leaked out, so we do this enough. So yeah, bottom of that one, side of that one, and one more top of this one. It's right up here. So, let's see, we'll skip a row. We're gonna go all the way back, you're right. That's skipping 2 rows, but you almost got this one. Okay.
So the main principle of this is that cold hydraulic fluid acts similarly to plug.
Yeah, cold hydraulic fluid would act similarly to a plug filter.
So this way, the system can tell which is which and only allow the filter to have pops.
Yeah, yep. Huh. There are other styles. Obviously, we got electric. It could flash a light in the cockpit. Hey, your hydraulic filter is plugged. Which on this one, if we've got electrical switches on there, that's a pretty good idea. Or you might even have the gauge that says I got a certain pressure drop across my filter. Visual with a memory is the buttons, right? That sounds kind of silly, but visual with a memory is the button that pops. The other visual with a memory, I think we get later in the year, but if you've ever seen a gauge that's got the needle, and then there's a little red thing that basically hangs off to the side of the needle. As the pressure goes up, it pushes the little red thing over with it. So now our pressure went up. Where'd my blue one go? Oh. Now my pressure went up to that point, and it pushed the little red thing with it, and then the pressure comes back down, and it's running here again. So sometimes if they use that word visual with a memory, is there'll be a little indicator that gets pushed by the pressure gauge, and if the pressure comes back, it'll leave a little needle there saying, hey, we got up to a certain PSI, just so you know, that's the highest I've seen. So that's one other version of what we would call a visual pressure gauge with a memory. It's like, we got pretty high here. I haven't seen those, because I don't fly big aircraft on hydraulic systems, but when I'm flying aerobatic aircraft, just the Citabria, it's got a G load meter. That's the same idea, is it'll read the highest G's, and then it'll leave an indicator up at the highest G's you got while you were flying. Same idea with these. Pretty much already talked about the bypass. Normally, we're not gonna change the filters. I'm gonna use the word unless they're dirty. They might live in there for a pretty long time, but that's gonna depend all on the aircraft and what the aircraft asks for. They're like, hey, are we gonna change these every, and often it's not gonna be hours of flight, because we're talking big aircraft. In regs class, you probably talked about this. You get into big aircraft, and they count cycles. So how many times did it take off and land? Take off and land. So they might say, hey, you're gonna replace that every number of cycles or something like that. But normally they live a long, long time in there without an issue.
How often would you inspect it?
I'm gonna say depends on the filter, depends on the airframe. There's fuel filters on the PT6 that use the exact same filter as the hydraulic filter on the Beechjet. It's this filter. I believe those ones, it's on the annual inspection list. Hydraulic filters, I think are more of a on-need basis, like if the indicator pops, but you'd have to check. If somebody wants to look it up in the Beech manual, somewhere in that 6,000 pages that you're all gonna be responsible to understand if you're working on the beach. I hate those rules. It'll probably tell you, but you have various filters and they're probably not even all the same amount of time. All right, Amanda, I'm getting ready. I passed them all around. I'm getting ready to check this because Tiki thinks it's time to check the filter. She probably read it in the manual somewhere, right? It's in the manual. What do I want to do before I unthread this?
Hit it with some WD-40.
No, it's hydraulic fluid. We shouldn't need WD-40. It's a really simple answer. You're going to be like, well, duh. But I got to teach you, because if you get the answer wrong, you look silly on your written. Depressurize it, yes. You wouldn't ever want to pull that off without depressurizing the system. And that's a silly, easy answer, but they'll ask it a couple different ways. You don't ever want to check that filter before you make sure there's no pressure on it. Tiki.
So, the Beech manual, when we were doing the filters, said depressurize the system, and it refers you to some chapter in 12.
Yep.
You go to that, and it's basically just unscrew the cap.
So the issue, yeah, keep going.
In my mind, that should also be empty the reservoir, or else the reservoir goes straight through that, right?
Yeah, that is a thing with those ones, where the reservoir, you might get a bunch of filter. More so, and why they ask the question, specifically and a couple times, is just because you depressurize the reservoir, does that automatically mean that every filter in the whole aircraft is depressurized? No, not necessarily. And that's why they're pretty specific with it. You might have a filter on a pressure line going out to an actuator somewhere. Maybe it's the gear, and if you're sitting on the ground, your gear might always have pressure on it. So before you just go up to one, you're like, hey, I depressurized the reservoir, and start taking it out. And usually what happens with O-rings is they're gonna seal pretty good. It might be hard to take it out, but you're gonna get about until the O-ring comes loose, which is usually, right about the time the threads come loose. It'll go, oh! Yeah, and then you got, we don't mind so much that it's all over your face, but the fumes are gonna be what gets you. It gets in your lungs, and now you're going to the doctor.
So were we right in?
And draining the reservoir.
Even though the manual
Yeah.
didn't specifically.
I don't think, some of them have check valves, but the Beech one doesn't. So, sometimes you just gotta use a little logic with it. All right, last is just back to that torque wrench. So just a quick review, and I try to hit it when you're doing the Apache pump, or Aztec more likely. I always recommend you put a formula, write it down, put it on your desk, put it in there somewhere. But we'll do a quick one. We'll say you got your torque wrench. We're gonna say this is 4 inches, and we're gonna say your torque wrench is 12 inches. And we're gonna say the torque required is 70 inch-pounds. And you go, oh man, I don't wanna have to find that formula, so we'll just do it together real quick. And I have the favorite one that I have. So it's gonna be torque setting equals, and we're gonna say it is 70 times our original, which is 12, divided by 12 plus, I said 4 inches. So 12 plus 4 is what? 16, so 16, 70 times 12 is, oh, I should pick easier numbers. 840, so 840 divided by 16 is 52.5 inch-pounds. So, write it down somewhere, use it, practice it, because I was kind of like you at one point, except dumber. And I never wanted to use an extension, because I'm like, I gotta go find that formula, it's so hard to do. And I'm like, it takes 30 seconds. It takes 30 seconds to do that. So don't be afraid of the formula with your torque wrench. And I think this is where I learned that you can put a box end wrench on the end, because none of my instructors told me when I was going through. Never gonna forgive them for that. Man, if you put a box end wrench on the end of your torque wrench, it just makes life so much easier so often. Crow's feet are nice, box end wrenches are nicer. Just what I'm saying. You ever get those little mini sets of box end wrenches that are like 3 inches wrong? Oh, it's like a crow's foot for half the situations in life you'll ever. So, anyway, another tool. Alright, that's all I got for today. It is lab time. Monday, we're doing power packs. It'll be fun. Randall went over with me, and we got the 206 all jacked up, did a couple gear swings. So, it's about this long a lecture Monday, and then we're going to go do a little tour of the LLC and watch some gear moving